Good morning to everybody, and welcome to the webinar of today. My name is Miriam Gangi. I'm in charge of communication and press office of ANFIA, the Italian Association of the Automotive Industry. ANFIA is one of the 11 partners of SURE5.0 project, a European project within Horizon Europe program. SURE5.0 project aims to support European SMEs in going through their digital transformation while becoming more resilient, sustainable, and human-centric. The project has been lasting 3 years, and we are almost at the end of the project itself. It consists in two separated acceleration programs, each one structured in a sequential two phases approach. The first phase is concentrated on assessment and recommendations referred to the specific solution the applying SME is proposing, while the second phase is concentrated on the actual implementation of the 5.0, the Industry 5.0 transition plan. The event of today will feature 3 industry leaders sharing their successful stories of digital transformation. We will discover how, participating to SURE5.0's acceleration program, they managed to integrate Industry 5.0 principles in their business models. So today you will gain some practical insights on how Industry 5.0 is shaping the future of the 3 sectors covered by this European project: mobility and transport and automotive, aerospace and electronics. So the agenda of today will start with a speech given by Michael Fiammengo, Director of Organization and Business Development at T.I.P.S, who will explain how companies can transition from Industry 4.0 to 5.0 with a practical approach. T.I.P.S is specialized in the design and manufacture of test interfaces for semiconductor test and supports its customers throughout the whole product life cycle, from R&D and test concepts to engineering and design to production and the whole after-sales maintenance and support. He will show us how the corporate culture can become a battleground and how to manage the complexity of such a transformation. The second speech will be given by Val Stavrer, CEO of Visign Space Tech, who will talk about digitalization and materialization. This company has a dynamic collection of aerospace-related projects and prototypes at different stages of development. He will describe innovation trends and digital enhancement in the satellite industry, and will also share his conclusions and enhancements, his conclusion and achievements about new technology implementation in some processes and products. The third speech will be given by Kaan Özgen, co-founder and program manager at Turncircles, who will explore the Industry 5.0 concept applied to electric motors. Turncircles indeed is a startup company specialized in developing custom electric motor technologies that provide superior power-to-weight ratio for small to medium-sized applications in robotics, drones, e-bikes, and electric-powered tools, and also other electronic systems. Turncircles also designs and manufactures generators and alternators and electrical generators for combustion engines, as well as wind turbines. So now we can start our webinar. I'll only remind you to keep muted your microphones and switch off your camera in order to save band, and also to use the chat of this webinar for your questions, since at the end of the three speeches we will have a Q&A session, and we will deal with your questions. So now let's start. I'll give the floor to our first speaker, Michael Fiammengo, Director of Organization and Business Development at T.I.P.S. Please, Michael, the floor is yours.
Let's start. So my name is Michael Fiammengo. I'm responsible for the organization, and my presentation is called When Industry 4.0 Meets 5.0. And we have adapted a kind of practical, holistic approach, which I want to go through with you together. First of all, I want to say a few words about my company. So T.I.P.S stands for Technical Innovation Physical Solutions. We are focused on design and development of test interfaces for semiconductors, what means we are contacting semiconductors directly after manufacturing on a wafer level to ensure their functionality, and we are specialized on test technologies for high voltage and high power semiconductors. So our products are probe cards and probe card contacting technologies, test boards, mechanics, and with also some machines like the probe refresher to ensure the functionality of the probe cards. Here you see some pictures. So the first one is a cantilever probe card, the other one is a vertical probe card. You see these small needles here. These are contacting the semiconductors directly on a wafer level. So we are based in Austria, in Villach. So this is our manufacturing site. We have here research, development, design, manufacturing, and the complete maintenance support and the global sales. So we produce everything in Austria and we ship everything from here. So our customers are globally based in all countries. So we have a kind of export quota around 70%. So first of all, I want to start with these three pillars of Industry 5.0, which was for me a kind of, let's say, a new approach to focus on resilience, sustainability, and human centricity. I mean, especially sustainability is a huge topic in the last years, especially in Europe, luckily. And also after the pandemic, resilience became very important, and also during the COVID pandemic and the war in Europe, in the Ukraine. So this is something we focused also a little bit before this project, but with this project, it became much more into our focus. So the human centricity is something what is we focused also during this project in our systems. I will go later through it. So at the beginning of the SURE, I have called it three main battlegrounds where we wanted to focus on. So the first one was the corporate culture, because when you want to drive this transition with a holistic approach, you have to work on the culture of the company. So you have to put all the people on board, you have to align. And the second one is the infrastructure. So I will go in detail to all of these three main topics, and of course the complexity. So I will first start with corporate culture. So we realized that it is very crucial to act instead of react. So especially during the pandemic, during the next years in Europe, we were faced with a lot of insecurities regarding supply chain. So we decided to move forward, to focus on teamwork and to add this Industry 5.0 approaches into our vision. I think the most important part here before starting with such a transition is to integrate as much people as possible of the team. So this was something I really tried to focus on, to closely work together with all the employees and to align them on this topic. So because only when you have this kind of alignment, you are able to create the awareness for these important topics. So we live in disruptive times, so to foster curiosity and collaboration is essential. So we have integrated all the suppliers and customers into this topic, because it's not only about our employees, it's also about bringing suppliers and customers on board. I will talk a little bit more about this in a few slides later, because we've also integrated suppliers with, let's say, some kind of APIs and that stuff. So I think the corporate culture topic is, I have put here on the top the buttons for human centricity and resilience here, because this topic is very strongly related to human centricity on the one hand, and on the other hand to the resilience. So because when you and upskill people, you create also more resilient processes. Because we figured out that upskilling creates a kind of flexibility, what enables us to move people from one job to another job when it is necessary for it. So we have now created a kind of flexible manufacturing where people don't have only one competences. Yeah. So when there's a huge increase in one department, we can move people from the one to the other. So we were able to keep people during the crisis when the production was not fully, the capacity was not on 100%. So, and the other thing is, of course, education, an educational approach, what is very important in terms of human centricity and also resiliency. So the next huge topic was to reduce complexity. So you can imagine that producing probe cards and working on cutting edge technologies is very complex. So based on the sustainability and human centricity approach, it was very important to improve our workflows. So in the second, let's say, phase of the working on this second battleground, we were very strongly focused on improving our processes and creating value streams. So with also last year, it was a kind of overlapping with the SURE project, opening of our production hall 3, where we restructured our manufacturing floors. So the third mechanical workshop department became a new production floor, and we took this to really map a value stream to create a much better and more efficient process. Because I think one of the key points for manufacturing companies in Europe is to drive operational excellence into the processes. So here we have also worked very close together with a service provider from the SURE project, where we have integrated the continuous improvement process into our project management system, which stands the PWX, because it's called Project Works. And we have spent here a lot of resources how we can improve and map errors or incidences that occur during the manufacturing. So we have standardized here reports, and we made a very low-level approach for manufacturing workers to report this every kind of feedback or errors that occur during manufacturing. What means we made improvement available and feedback possible with digital systems for everyone in the company, very easy and very fast. And due to the documentation, it is also ensured that the right person receives the right feedback always in the right direction. So this was a very important milestone during the SURE project. And the next point is, I think, also to keep on this digitalization process and automatization process also. So this is something we will not stop doing it after finishing this SURE project. It's a way you have to continuously go, like continuous improvement. You have to continuously review your processes and standardize, automate, and drive automatization. So we've also reduced, let's say, this is very strongly linked to human centricity, as we have reduced, let's say, some simple tasks in creating process where we have aligned with our quality management. We have in our quality management defined all the departments, and to create a project is now very easy, going also through the digital software. This is something we have also adapted with an external service provider here. So, and the next point is, as we create now a lot of information due to this integrated continuous improvement process, the next point is, okay, how can you get data out of this? How can you get information out of this data? So we have focused also on analytics and on capabilities in business intelligence to be more able to, because I think this is something, especially in a disruptive environment, you have to make sure to act very fast and to make the right decisions, but you can only make good, or let's say the best decisions when you have the best data available and when you have a great overview about what's going on. And then you know where you have to spend resources and where you have to spend time to go deeper into these topics. So the next battleground is, I think, the infrastructure area. So we have focused on developing of response plans to be able to respond to whatever happens. So if it's a kind of this is strongly linked to resiliency, and because you never know if there is a blackout, a pandemic, or you need to make sure that you have the right response plan and you know how to act. So we also have invested into our cyber physical systems, and this is a real, let's say, a milestone. We have developed the so-called TMS platform. It's called T.I.P.S manufacturing system, where we have connected people, products, and technologies. So we have mapped at the beginning our technologies, our Industry 4.0 technologies, and connected this into a human-centric way. So we have built a kind of manufacturing executional system for our company, which is fully integrated also with suppliers, and in the future it will also be connected with customers. So to get live insights, when is my product ready, and to create also a digital identity for each product. So when you send it back for refurbishment, for example, you have a QR code and you scan this and you see the complete history of this product, for example. And the TMS platform is also linked to suppliers of components, because we were faced the challenge especially during the Corona pandemic, that some components were not available on the market, and it was I think it was also a kind of business model for many companies to just buy some electronic components on stock and then sell them tens the price. So we had some printed circuit board designs with some components on it, where the components costed before the pandemic, let's say, for example, 50 cents or €1, and then you have 200 of these resistors, for example, on the PCB. And after or during the pandemic, one of these resistors costed instead of 50 cents, 100 euros. So when you are not able to recalculate the price of this product at the same time, you really have an issue, because you cannot just take the price from the product before and say, okay, well, this assembled PCB costs the same price as 3 months ago. It is not the case, because the resistors, you need to source the resistors, and when you then buy for the components more than you sell the product, you have a huge problem. So this is why we connected with APIs our components database into this TMS platform to make sure we can calculate every time we get an order, we can recalculate automatically the complete layout and with all its list of materials. So this is something ongoing. So we have finished the first phase of this project of the TMS platform during the SURE with our external service provider. And I would love to show you more of this and to go further in detail to this, but I think we don't have the time for this today. So I will continue now on a very important topic. It's again the resiliency, very strongly linked to resiliency. So as you can see, the first, as we built this TMS platform from the scratch, it is also very strongly linked to human centricity and of course to sustainability, because we were able on the one hand to save resources, on the other hand, due to the integration of the people and the suppliers and the customers, we are able to create a very easy use platform which makes the job more comfortable and easy also for the people. And so for the cybersecurity approach, it is something that this is a very important sentence which I use for my work on this topic. So the more you rely on digital tools, the more important is the protection of the digital and cyber physical systems. What does it mean? So at one point when you run, let's say, very strong digital manufacturing floor, like we are doing now, so because we have a digital project management system where we can track all our products. We have started this development and progressed with the manufacturing system. Of course, you have the accounting systems running through SAP and that stuff. So, but the more you rely on these systems, the more important is the protection, because we see in statistics that cybercrimes are increasing very strong, and we were faced also some concentrated attacks from outside. So you need to develop also response plans here and spend a lot of resources to be here very strong, up to date, and to be on the next level regarding cybersecurity, because it's not like it was 10 years ago that you do a lot of paperwork. So we all want to reduce the paperwork to save resources. We all want to be more efficient with the use of digital tools, Industry 4.0 technologies like AI, cloud, and all that stuff. But the more you rely on these tools, the higher is the risk too. So it's also a kind of, it's an opportunity and it is a risk, and you have to use the opportunity and you have to reduce the risk. So this is why we have also focused here on a kind of holistic approach and used also resources internally and externally to continuously assess our security standard and to improve the level. So on the one hand, on a digital way, on the other hand, on a physical way to make entry barriers and whatever. So this is also a huge topic. I would recommend you to put a very strong focus on it when you see this as a kind of holistic approach. So thank you for your attention. This was my presentation, and I remain at your.
Okay, thank you. Thank you, Michael, very much for sharing your interesting experience in SURE 5.0's acceleration program. Now, I will introduce the second speaker, Val Stavrer, CEO of Visign Space Tech, who will talk about digitalization and materialization. Let me share his presentation.
Thank you. Let's begin. Visign is a startup. We have no corporate structure yet. And the only thing we produce is a prototype for now, ready for qualification tests. But with great support of the program SURE5.0, we finally launch our program to material level, from speculations through designs and models and plastic mock-ups to ready for qualification metal work. First of all, I want to say my great thank you to organizers for very smooth managing the process with their actual involvement and simply kindness, what is not the case anyway everywhere nowadays. What I will talking about is not a very popular thing. Small satellites, so-called CubeSats. Maybe everybody heard about them, but the small government-funded, non-government-funded satellites began in 1961 with Oscar satellite, this one, made by amateurs, amateur radio amateurs, and launched as a secondary payload along with the spy satellite. After 40 years of sporadic launches, finally in 2020s, it was introduced a special standard for such kind of satellites named CubeSat, which greatly enhance the launch rate. So CubeSats became very popular. They are 1 to 10 kilograms, and they've been recognized as an educational and prototyping platform. But during that development, making dominated the market for small satellites like this one. Here you could see what is the origin of CubeSats and why they have some limitation facing commercial applications. It's a rather do-it-yourself things based on old idea of Meccano, that's a toy bolting together different components and put it to work together. That's a main limitation of CubeSat standard, that is stake of PCBs that obscure the access to components. And during the development, all that components are placed on the table, connected in different way, and at the end of development, they are staked back. That is prone to error. Also, making possible to automate the assembly process. The wind of change came with unsatellite constellations. There is something like a Starlink, many satellites for single mission. That's communication or Earth observation. There is a few CubeSat constellations that make progress, but the mass production is became problematic and is virtually made the cost higher, development time longer. We believe some changes are needed. Instead of stake of PCBs in our implementation, it's planar configuration. Our recently patented solutions is built around the conjunction of two ideas, a low-profile form factor and multi-function structure that is parametrically designed and additively manufactured. The proposed new standards aligns with the latest design advanced manufacturing developments like metal 3D printing we used. That's setting our project apart from existing solution in the industry. We learned for failures of others trying to establish the standard to compete with a highly successful framework of CubeSats. We make our design back compatible with CubeSats, CubeSat deployer, so we could use the existing infrastructure. A typical nanosatellite design or build process that is material part of our work, but also it has a digital part that is less developed for now. The typical design and build of small satellite is a kit of part approach. Prefabricated COTS modules developed in-house are assembled and connected to work together. Once we have flexible planar layout, instead of pile of boards, we devised the idea of parametric model of satellite platform customized by the user. Instead, the user to customize material, the bus, the platform made in material, in metal, for example, it could customize the model platform will be manufactured by so-called rapid prototyping. Currently, we're working on digital alternative of satellite platforms, such a satellite platform which will be reconfigured for specific missions before manufacturing. In conjunction with additive manufacturing, can unleash the potential of our approach. However, the implementation of such a good idea is much more complicated than initial estimations. We will reach the market with simpler business model, bespoke nanosatellite design in-house, with more or less traditional methods. We apply a parametric design model that is usually embedded in CAD systems. The confrontation with the market will accumulate more data for future design automation. So what we achieved during the program, physical prototyping manufactured, done. Value chain established with companies included in SURE5.0 catalog. We contacted them and have ordered them manufacturing 3D printing from metal, for example, services. So at the same time, we filed a patent application with our solution. Here is our so-called MVP. That's only metal part. Now we will add some PCBs to before qualification tests. So space qualification scheduled. Again, with support with SURE5.0. One of the results of the program participation was better understanding what is the what is the Industry 5.0. It sounds like a buzzword, but we find that is far from the truth. And draft 5 for company structure according to vision of Industry 5.0. Finally, lesson learned. New technology like additive manufacturing have their advantages along with their limitations. Before to begin to work in material, we have a little knowledge about real limitation of metal 3D printing. Qualification and certification is critical. The paperwork is the single more expensive thing in space industry. That is what we learned, and we overcome that barrier with SURE5.0 funding. Thank you.
Okay, thank you very much, Val, for sharing your experience. Now I will give the floor to the third and last speaker, Kaan Özgen, co-founder and program manager at Turncircles. Please, Kaan, share your presentation and let's start your speech.
Okay, so thank you. Yeah, we are Turncircles. We make custom electric motors that are axial flux and permanent magnet brushless motors. We capitalize on the PCB stator technology that replaces the conventional windings where several manufacturing steps are involved and several components. So we reduce the number of components on an electric motor and provide very efficient solutions. The solutions the customers really need. If you are not looking for a custom electric motor, then you would need to compare data sheets and from hundreds or thousands of options you have out there and trying to find the best fit. While it will be probably enough, you will be most probably integrating an oversized motor to have your needs, which finally leads to inefficiencies. So we have received the support from SURE5 that was very valuable, and we have streamlined our processes of creating this custom built motor while supporting the configuration process of our customers, but also integrating our suppliers in automating the manufacturing of this motors. Currently, on our website, when we first, let's say, receive our customers, they go through this little customizer. It does allow you to little play with it, give you a flavor of what it looks like, configuring our technology. where you can scale the motor or add additional stacks where where you would then multiply the power, and also make a very generic inputs in terms of your power supply. So with the support we have received from SURE5, we've streamlined this process end to end. And now what you just saw, this simple customizer on our current website, it became this platform now. And so we collect more parameters and requirements from the customers. And that's also where we step in to that what kicks start the process. Yeah. So the configuration the customers are doing on the cloud platform, it goes simulated automatically. Then we generate now automatically the manufacturing documents, be it the step files, be it the Gerber files, and these go automatically to the manufacturer, and you receive basically the output, the electric motor. And not only that, we have integrated sensors. So we turned our electric motor into IoT devices, where we now collect operational data like temperature, vibration on XYZ axis, and where we then conclude on vibrations and noise of the motor. And all of this information we collect now, it goes back into the configurator in our cloud platform. And the users can then see their operational data. The operational data will be analyzed with some machine learning algorithms for like statistical process control. If the vibrations are in expected limits, if the temperature is where it has to be. So this is being continuously analyzed on our platform now to provide users with, let's say, predictive maintenance data and a warning. Okay, you have to now change the bearings, for example, or you have to reduce the vibration on the motor. Something is wrong, maybe. So these kind of preventive actions are being provided that then contributes back to the sustainability of the specific application of our customer. And not only that, it also records the entire operational data throughout the life time of the motor. And at the end or during the operations, the system can always say, okay, this motor is, let's say, oversized for your current application, or the motor, if it heats up, you can also conclude it is undersized. You would need to increase the torque or increase the speed, whatever kind of, let's say, intelligence is what we introduced. And once the motor comes to the end of life, we have now the possibility to get back the motor and then recycle it. And this is all made possible through implementing digital twin. So from the moment you start your configuration, you get an identifier, and this identifier gets linked with the sensor identifiers that are implemented onto the motor. And so we can track until it comes back and gets recycled. Yeah, so we're still keeping the business model, even though we've also made some progress on that. We still make the build-to-order electric motors. We implement the IoT sensors, and that is then the data gets linked with the digital twin in our platform that enables predictive maintenance, continuous monitoring for the optimized operations, and also to prolong its lifetime. And at the end of the life, our customers don't just throw away the electric motor, but they return it to us, and we do disassemble and forward the parts to our suppliers, initial suppliers, for the recycling. And that is even being done for free. There's no extra cost. It's it was just our responsibility as a manufacturer to implement this process in place. Yeah, and through this digital twin we put in place, we have the possibility to just recycle and close a use of an electric motor. And this entire process we support with AI capabilities, and that's why we call it AISCN, so AI supported control network. From the creation, definition of the motor, creation of the motor, operative use, and then recycling. On each and every phase, we get support from digital capabilities. So we call this a quattro-facet efficiency house. It's basically, this is still our vision. So we have achieved some, but we have plans for improvement. So the first one is in place, the motor customization. We've developed the cloud platform. We finalized or matured the cloud platform with the help we got from SURE5. And we have also implemented some machine learning algorithms for predictive analytics. Yeah, so the third one, predictive efficiency analytics, is also in place. And the intelligent motor evolution, as I mentioned, if the motor is oversized or undersized, you would get suggestions or recommendations from the platform that you should opt for a bigger motor, or a smaller motor, or a faster motor, whatever. So this we've managed to put in place. The one remaining is for the more efficient control of the electric motor, is so-called dynamic PID optimization. So you have in electronical control, you have this PID setup. Normally you do it once, yeah, and then you start your operation. In some controllers also provide you the possibility to have specific PID parameters for the range, speed range, let's say 1 to 500 RPM, and then a different parameter set for 500 to 1000 RPM, and so on and so forth. Some controllers provide this possibility. Here, what we would like to include here is the continuous parameter calculation and adaptation of controlling motors on the run, so during the operations, and that will then secure the highest control efficiency of the motors. So this we had to leave out of the scope because of limited time and resources we have. But this still remains our vision. Finally, I'd like to highlight what we have did achieve with the SURE5. So our cloud platform, the first first block was on technology readiness level 3. With the SURE5 support, we brought it to technology readiness level 5 degrees. So the automated simulations, where the simulation work gets integrated into this end-to-end life cycle. It existed as an idea, but we didn't develop it. And after SURE5, we achieved its integration to TRL3. The hardware didn't make much change. Also, given the time frame of the SURE5 program, it's really difficult to work on hardware as it takes time, yeah, the delivery of the parts and the manufacturing of the parts and so on. And the IoT integration, sensor integration, you see, it was an idea, but it wasn't existing, so we brought it straight to TRL4 level. Finally, the predictive analytics, where we analyze the data we collect from the motors, also didn't exist, but we have developed it in the SURE5 program. So overall, these technologies also need to be integrated, where you see the IRL, so integration readiness level. These also now have to come to a maturity level so that the end-to-end chain would work seamlessly. So right now we have an overall readiness level of 5 out of 9 scale, but we are working on it on our pace and resources as the resources become available to finally offer this to our customers. So our experience with the SURE5 program is really appreciated, the support we have received. We've accelerated our AI journey. So many ideas we had on the backlog, we were able to realize them with the SURE5 support. And we now have really unlocked new features that we can provide to our customers. So we do that currently already, not for everybody, but we do introduce the new platform to our customers and say, okay, this is still in the alpha version, and some of the customers get access as test users. This also brought us to new partnerships, as we have looked for partners, for suppliers to work with on the catalog or outside the catalog. We made great partnerships, which I hope will last longer. What we would do differently, I mean, if I were to do SURE5 again, or maybe SURE6, who knows, one day, I would rather think outside the service provider's catalog. To us, it became quite late on the timeline, clear that we could look for any service provider and get them registered into catalog. And that could also work with freelance workers within in Europe. So this became us clear quite late in the journey. So we were somehow limited with what was in the catalog at the beginning. And so also we've seen this end-to-end life cycle. And so we were touching a very, let's say, long chain of processes, which is then ended after the given time and resources that we have there, a little TRL3, TRL7, TRL4, but like the whole chain didn't come to TRL7 or above. So a strategy would be rather maybe better to focus on one and then make it develop it till the end. And again, I would really prioritize software developments rather than hardware, because given the time is so limited, there's really not enough time to do hardware developments. So thank you very much. We are very glad and thankful for the opportunity, and we believe that we have done the most out of it for Turncircles.
Thank you. Thank you very much, Kaan, for sharing your experience with the SURE5.0 project. Thank you very much to our speakers for the interesting insights they gave us today. And thanks to all the participants of this webinar. Let's see each other for the next meeting that will be probably in April. Thank you very much and have a good day.